Heat emitters part 2. This is looking more at radiator maintenance and very briefly touching on underfloor heating as well. So the key objectives for this part of the session, I want you all to be able to state some of the common maintenance requirements of radiators and describe how to fix them. Describe the order of operation when draining a system and describe the pros and cons of underfloor heating. There can obviously be issues with radiators, as there can with any part of the system potentially. The main issue is to do with them heating up or not heating up, or partly heating up essentially. And there's different causes for these. One could be a complete airlock. If it doesn't heat up at all, it might be completely full of air, or there might be an airlock in the pipework. It could also be a result of a poorly balanced system. It could also be potentially an issue with radiator valves. Or if the whole system isn't heating up, then it could be an issue with the boiler or pump. But if it's individual radiators, these are the most likely causes. Radiators can also have cold spots. For example, if it's cold at the top, the likelihood is the top half is full of air. And if it's cold at the bottom or in the middle of the radiator, the cause is most likely a build-up of corrosion, which we'd describe as sludge, generally speaking. Okay, so if the system isn't balanced correctly, again, that can cause some radiators not to heat up. The further the radiators from the boiler normally. And we're going to look at that in a little bit more detail in the next part of the session. But long story short, if you restrict the flow to the closer radiators by closing down the lock shield valve till it's almost closed, then that will force the water out to the further radiators and essentially balance the system, so the system heats up sort of equally and the water doesn't sort of short circuit through the closest radiators. So in regards to fixing an airlock, well, sometimes that could be literally as easy as just getting your radiator bleed key, open the bleed valve on the radiator and sort of let the air out until water comes through. You would want to make sure that you keep a cloth there to hand to catch some of that water when it does start to squirt out, because it can be discoloured due to the presence of corrosion in the system. If the airlock was in the pipework, potentially you could sort of force that through by closing down all of the other radiators, turn on the heating system, and hopefully the pump could then push that airlock through. Build-up of corrosion. As we've talked about, the build-up of corrosion, some people call it sediment, some people call it sludge, can sort of block up the radiators. Most radiators are made out of steel. Steel's got iron in, and if you have iron, air and water, you're going to end up with atmospheric corrosion, which essentially causes the steel radiators to rust. And these products of corrosion can start to block up the radiator, like you can see up here, and cause cold spots. The sludge or sediment or corrosion, whatever you want to call it, can also damage the components in the system. So that is a really big issue, corrosion in heating systems. You need to be aware of it, and that's part of the reason why we try to minimise the amount of air in the system as well. One of the ways, alongside sort of trying to remove air wherever we can, is to use corrosion inhibitor. And you put that in normally as part of the commissioning process right at the start, and you should re-add it every time the system is drained down and refilled. Another good way of removing the sludge during an everyday operation is by installing something called a MagnaClean. A MagnaClean is a great bit of kit, and it'll essentially pull out those particles of iron, because it's iron oxide, still magnetic. So as that stuff flows around the system, as the sludge flows around the system, if you put this on the return just before the boiler, it should pull out the majority of the sludge from the system just doing normal operation, and periodically you'd need to sort of take this out and clean it off, and then reinstall it. So flushing, power flushing a radiator and or system, we're just going to very briefly look at this. If there's a big serious corrosion buildup in the system, a lot of radiators have got cold spots, then it might be worthwhile for the customer to power flush the system. You need specialist equipment for that. If you just got sort of some minor corrosion issues, you could use system cleanser, and then sort of put some system neutralizer in the system as well. Obviously follow the installation, not installation instructions, follow the manufacturer's instructions for that, as you use it, and make sure you use it appropriately. Okay, if it's just one individual radiator that there's a problem with, what you could do is you could isolate that radiator, drain it down, and flush it through just using a hose. So what's the procedure for isolating an individual radiator? Well, you can switch off the radiators valves at each side. It's worth maybe putting a retaining cap on a TRV if it's likely to be off the wall overnight, because if it gets very, very cold, there's a sort of inbuilt frost protection in there that would actually allow the water to flow through the valve, and obviously if there's not a radiator fitted there, it's going to make a real big mess of the carpet. So it could be worth putting a retaining cap on that if it's going to be off the wall for a period of time. If the radiators do become badly corroded, they might need to be replaced, and when you replace them, you might well want to replace the valves as well. So one way of doing that is to drain down the system to just below the radiator. So if it's on the second floor, first floor, whatever you want to describe it as, you could then sort of drain the water until it's underneath that floor and then replace the radiator. Or you could freeze the pipework to the individual radiator and then quickly change the valves and sort of go from there, really. So worth noting, to drain a sealed system, you'd need to make sure that you turn off the heating and hot water, ideally at the fuse switch spur. Tell the householder obviously before you switch it off, and sort of give them a sort of heads up of roughly how long it's going to be out of commission for. Leave a note next to it to make sure that it doesn't get switched back on by mistake. Connect the hose to the drain valve, take the hose outside, open the drain valve, let the water go, and then after a minute or two, go up the stairs and open up the bleed valves. And what this does is it allows the air in, so the water can drain out of the system, can drain out of the individual radiators, because otherwise the water will be stuck in the radiators because it'll be in a vacuum. So it makes it much quicker and easier for the system to drain if you open up the bleed valves. So firstly, if you're draining down the whole system, you'd start with up the stairs, open the bleed valves up the stairs, leave it a little while, then go down the stairs, check, just crack it open on one of the ones down the stairs, see if lots of water comes out. If it does, then close it back up and leave it a little while longer, and then then go back and check again, and then eventually you sort of hear a sort of hissing sound, and that's actually sort of air going into the radiator, and again it's helping with the assistance of the draining of the downstairs radiators as well. And that's how you sort of fully drain a heating system, essentially. Make sure that you close them all before you refill it, and then just open them one at a time as you're filling until each radiator is filled. Worth noting, if it's an open vented system, make sure you turn off the supply to the feed and expansion system as well, because otherwise the system would just automatically be refilling all of the time through the feed and expansion system. Okay, briefly going to look at underflow heating now. Underflow heating is exactly what it says on the tin. It's heating that's fitted under the floor. So it heats the floor, and then the floor acts as the heat emitter, essentially. It can be installed under wooden floors, it can be installed under laminate floors, it can even be installed under carpet, which is not really recommended. But yeah, then it sort of heats the floor, and the floor acts as one big giant heat emitter. So pros and cons: it's got low temperature operation, which is suitable for heat pumps. It can also mean that the boiler is most likely to be working in condensing mode as well, which is potentially means if it was used with a condensing boiler, it would work quite efficiently. It would give even heat distribution throughout the room, and there's no visible heat emitters as well. Big con is the cost. The cost of an installation can be quite high, and also the hassle factor for installation, particularly in existing properties as well. It's a very slow heat up time, which sometimes means people actually install them alongside traditional heating systems. So the traditional heating system with the radiators will give you that initial kind of burst of heat at the start, and then once the underfloor heating's got up to temperature, it would switch off the traditional side and circulate the water through the underfloor heating. Yeah, like I said, difficult to retrofit in existing properties, and could induce sweating in furniture. That just could damage the furniture if it's not used to having that sort of heat coming up from the ground. Now it's time for your task.